All right, so this is kind of like a double quiz. It's a little slightly lengthier than your average quiz. So what we have here, going back, first of all, something I want to mention that's going to show up on there is just if it talks about states of matter. You guys know what these are, but I just wanted to make sure you guys saw them actually when we did the stations lab way back then. But so states of matter are going to be our solid, liquid, gas type deal, right? All right. So you might be seeing some pictures of those. We might be talking about conservation of matter. Actually, we will because that was the biggie from that week. You need to know what this means. Okay. So conservation of matter, what that means is when we go through physical changes or chemical changes, the number of particles before change will be equal to number of particles after the change. Okay, really what it says is that matter cannot be created nor destroyed. So when we have reactions, we're not going to see something just be there and then disappear because of the change. We're not going to see particles just appear from nowhere. And we know that measuring the amount of particles, what is that called? What type of measurement is that when we measure just the amount of particles? What is that called? The amount of I know you guys are writing. Mass. I can't. Oh, yeah, you can talk when I ask questions. Absolutely. Yes, mass. Okay, so mass is the number of particles. What if I said, what is the what is the amount of space the particles take up? What would we call that measurement? The volume. Okay. So this conservation of matter or conservation of mass, whatever the mass is before the change should be the same after. Now, sometimes this is not true. Okay. We only get changes when particles during the change enter or leave the system. So, like if I have something evaporate, could the mass change? Sure, it could, because some of the particles, when they evaporate, they're turning into vapor or gas, they're going into the air, they're leaving the system. We can't find the mass of those after them. So it does appear that the mass went down, but did we really lose? Is there really less matter? Like, did matter disappear? No, matter just left the system. Okay? In some of these combustion reactions, we actually had particles enter the system because O2 in the air is one of the reactants of a combustion reaction. So O2 that was in the air that we didn't find the mass of to begin with is actually present at the end. So conservation of mass. Now, if we think about this is important. Make sure you pay attention to this. But we need to be able to show that in models. Okay, show in models. Particles before and after equal to particles are equal. So particles before equal particles after in terms of number. Now, could we have some of them shown as leaving the system or entering the system or whatever? Sure, but we need to show that whatever particles we had at the beginning of the change are present somewhere at the end. Okay, so another thing we've been doing, we need to be able to make a graph. So we need to be able to title it, use appropriate variables for the x and y axis, label the x and y axis. We need to have the proper scale so that our graph is taking up a majority of the axis, not like tiny compared to what we have available to us. And then, very importantly, we need to be able to make a best fit line in that graph. Okay? With that best fit line, we should be able to make a for every statement. And the for every statement, the reason why that's important is the for every statement is really telling us what that slope means of the best fit line. So along with for every statement, we're going to have to be able to find the slope, which of course we pick 2 dots on the best fit line. The first dot we pick will be x1 and y1, and then as we work left to right, we'll pick another spot on that line, which would be x2 and y2. And then the slope, we're going to go y2 minus y1 divided by x2 minus x1, and that would give us our rise over run. Okay, so the only other thing after that, what we need to be able to do is we need to be able to do significant figures stuff. Okay? So, I mean, we've done things with using the correct level of precision in our measurements. What I want you to be able to do with this is I want you to be able to still do that. Look at a measurement and use the right precision. I want you to be able to tell me how many sig figs are in a number, significant figures. I want you to be able to do a calculation. And I will say this, emphasis on multiply and divide rather than the adding and subtracting, okay? Because we're going to use that a lot more often. Now, what that means is you're also going to have to understand rounding, okay? So if you look at the next digit, 5 or higher, round up. 4 or less in the next digit, stay there. Okay? Because when we do a calculation, like if we do, say, 2.1 times 3.000, what I would do, depending on how good you are at math, you could use a calculator, not a phone, of course, but use a calculator, just multiply 2.1 times 3. And maybe this is a bad example. Let me do another one. I'm gonna change this. I'm gonna change it a little bit. Give a little bit better example. All right, so I've got 2.1 times just 3. No focus. 2.1 times 3, just 3, no decimal places. So plug it in into the calculator if you need to. It's going to come out to be 6.2. Now, our rules with significant figures for multiplying and dividing, what we do is we look at the numbers that were involved in the calculation, and we just pay attention to the number of significant figures. So 2.1 has 2 sig figs, the 2 and the 1. 3 only has 1 sig fig. So which is less, 2 or 1? 1. So our answer should only have 1 sig fig. So if I look at this first digit here, that's my first sig fig, is the 6. So now I look at the next digit. If it's 5 or higher, I'm going to round up to 7. If it's 4 or less, I'm going to keep it at 6. In this instance, it's 4 or less because it's a 2. So my actual answer is 6. Okay? You have a question? But that's how we do the multiplying and dividing rules for significant figures. Okay? You guys have any questions on that at all?